Good morning, Skopje. Thank you for having me. My name is Erik Rasmussen, and today I'd like to talk to you about state machines and how to use them to build amazing UI. But first, we need to talk about what are state machines. Well, I dare not ask the audience how many remember this particular device, but it's a good representation of what a state machine is. When you're in a given state, you can have an event that moves you to another state, and when you're in that state, another event can move you back to the first state, for example. But the important thing is that when you're in the stopped state, hitting the stop button doesn't do anything because you're not listening to that event. But the play button does do something, and conversely, when you're in the playing state, hitting play doesn't do anything, but stop will transition you. And notice that there are not an infinite number of states, which is why they're often called finite state machines. So before we get into building something, we need to talk about some terminology. First, a state is one of many finite states that a machine can be in. Excuse me. This is represented by a box on the state chart. This is not, however, analogous to React use states or Redux or anything like that. This is just a representation of being in a state. A transition is a predefined way to move from one state to another. This is represented by an arrow on the state chart. An event is a value that you give to the state machine that may or may not trigger a transition to another state. A guard is a predicate to evaluate to determine if a transition is possible. And an action is a side effect that can be fired when a transition occurs or when entering or exiting a particular state. One of the most common actions is to update a value in the state machine's context. Context is a store of data inside the state machine, and this is analogous to useState or useReducer or Redux. It's just a place where you can put information. And an actor is an entity with which the state machine can interact. Often asynchronously, this can be like a callback function or an async function that returns a promise, or an observable that can emit mini events, or another state machine. You can connect as many state machines together as you see fit. Okay, so now we've done with the boring dictionary part. Let's look at what we're gonna try and build today. I'm gonna build a common combo box. We've all used these all over the internet. Our requirements are we need to search as you type, and we need to show a little spinner while searching so the user knows that something's going on. And we need keyboard navigation to select the item that we want to choose. And you should also be able to choose via mouse click. Okay, so the library I'm going to use to build this is called xstate. It is by far the best way to build state machines in JavaScript. And the way we scaffold up our machine is like this. Because we're professional developers, we're using TypeScript, not JavaScript. So first, we're going to set up the type for our context and our event. And we're going to give those types to this setup function that xstate gives us. And that's going to give us a way to call create machine. And down here, we will put the definition of our machine, how it's going to work. Okay, now for the fun bit. We're not going to code this machine directly in code. We're going to build it visually using a visual editor. There's a VS Code plugin by the people that made xstate that lets us do this. So let's open up this visual editor here. And this is just an infinite canvas that you can drag around on. And I can click to add a new state. And notice on the left that as I'm creating this state, it's building out that state machine definition over here. So I can add a new event, like query changed, and that's going to take us to a searching state. Notice on the left how it's all getting coded for us. And from there, we can get found results back, and then we can be in the selecting state, and from there, we can select one of the items, and this is actually going to take us back to showing no results, because we're not choosing any results anymore. So we can drag these guys around, we can do whatever we want, make it as pretty or as ugly as we want, and this is all stored over there on the left. See that line 13? The location of where we're dropping all these things is stored over there, so that when we commit our code to GitHub and our colleague opens it up and looks at this state chart, it's going to be exactly as pretty as we left it. Okay, so now over here, TypeScript is upset because we've introduced some events that we haven't defined in TypeScript. So let's go and set those up. So we've got query change, and this is going to have an extra bit of payload that is the query that has been typed in. That's our string. And then good old Copilot. We've got found results, and that's going to have some results that are not actually strings, but a person type that I've defined that we can import. And lastly, our select type. Okay, so TypeScript is now no longer angry with us, and we can continue. So we've defined the strongly typed versions of each of these events that we've drawn over here. Okay, so now that we trust that this is connected to our code, we're going to jump into the visualizer and build out our state machine. So this is where we're thinking about how our component should behave. Okay, so on our query change event, we're going to want a side effect, which is an action, which we set up here in the editor, to save the query to the context of the machine, so that we have it later in searching and for displaying to make it a controlled input in React. But we don't necessarily always want to go to searching when we get a query change. So what we can do is we can click this add transition here, and we can make this, we can add a guard to only go into searching if we have a query. So if you've entered an empty string or something, then we don't want to do that. We want to stay in no results. So here we're building our logic visually in a way that is fairly easy to read. Now we need to add a few more bits of our payload to be saved. So things like our selection. So we need to set our selection into our context, and when we get results, we need to save those results also. But what if we don't have any results? Well, for that, we can add a transition like we did before and set this guard so that only if we have results are we going to go into searching. Otherwise, we're going to go to the aptly named no results state. So here we're building out our logic. Okay, now in our searching state, we want to invoke an async actor to go to the server and get our results. So that's how we set that up there. But what happens if the query changes while we're searching? Well, we want to stop searching and re-enter searching with a new query, right? So we could do that by adding some arrows from the searching back into searching. But if we think about it, really we want, anytime the query changes, no matter where we are in the state machine, we want to stop what we're doing and go back into searching. So the way we can do that is we can drag this guy here up to be a sort of global event. So no matter where we are, this got broken, we can fix this. So no matter where we are, if we get a query change, we're going to go into searching, or no results if there's no query. Okay, so let's hit auto layout here, and it does a pretty good job, but we can see how the flow through our state machine here. So we get a query change, we go into searching. If we have results, we go into selecting, and we select. Then we go back into, we set the selection, and we go back to no results. Okay, but we got a few more actions to add, like clearing the query. Like when we select, I think we should get rid of the query that we've stored. And anytime we have found results, we want to highlight the first item so that you can just hit enter to select it. And when we don't have any results, we want to clear the previous results that we had. So we can add an action for that. Okay, now we need to give some love to our selecting state here to handle our keyboard stuff. So let's pull that out for the moment so we can edit it over here. And what we want to do is we want to invoke an actor that's going to listen to our keyboard events. And then that's going to emit events to us. And here we can handle this event and stay in the same state. So for example, we could have highlight next. And that's going to need its action to increment our highlighted index in our context. And obviously the corollary of highlight previous. And that needs an action. And when we mouse over one of the options, we need to set the index, not just increment or decrement. So we do that, and we can edit the event name over here too. Set highlighted index, and then its corresponding action. Okay, so now in our selecting state, we're handling all the keyboard events, and if select is also an event that we can fire on enter. So that's looking pretty good. So let's hit auto layout again. And it looks a little messy, but you can sort of see that those are all things that happen there in selecting. So let's think through this again. So we start off in no results. That's what that little arrow thing there means. And at any time in the state machine, we get a query change. And that's going to take us to searching, which is going to invoke the search. And if we have results, then we're going to go into selecting. If we don't, we're going to go back to no results. And similarly, if we don't have a query, we're going to stay in no results. But if we do, then we're going to be in selecting, and then we're going to listen to these events and adjust the selection, and then hit select and make the selection and go back to no results. So sadly, the fun drawing part has come to an end, and now we have to go and actually write the little bits of code to make this work. So let's go back over to our machine definition here. And we've got a bunch of red squigglies, courtesy of TypeScript. So we've added a couple more events. So let's define those events first. They were highlight next and highlight previous and good job Copilot. We needed the index, very good. And we've got a problem here with the semicolon up there. And so now Prettier's happy. Okay, so we've got all our events now. Now we need to do our strongly type our context. So in our context, wow, Copilot, well done. So we've got our query and our results, and one thing it missed was we need a selection that may or may not be defined. Okay, so now we need to define our initial context that satisfies that type. So we can go into our state machine here, definition, and say context. And we want an empty query string so that our input is controlled and our results, and sure, -1 is fine. And we don't have a selection to start with. Okay, so let's add our guards. We've got have results and have query. So we define that up here in our setup. Nice try, Copilot, but that's the older syntax. The newer syntax is ignoring the first parameter and then defining a strongly typed params option. And sure enough, if we trim and do the length, that's good. That means we have a query. And Copilot figured out the next one. If our results length is greater than 0, then we have results. Excellent. Okay, now our actions. So, wow, Copilot's getting excited. That's the wrong syntax again. So the way we do this is with this assign function that xstate gives us. And query is the key of our context that we want to assign to. And it's the same syntax of strongly typed params, and then we just pluck the query out of the params that we were given. So in the interest of time, I'm going to do a little copy paste here so that I don't have to define literally all of these actions. But I think you'll see that they are all just this assign action of strongly typed params and things like highlighting the first is just hard coding 0, and the rest are the increments, take what our previous index was and increment, etc. So this is all pretty clear, and there is some boilerplate aspect to it, but guess what LLMs are really good at. Okay, so how do we call these strongly typed guards and actions? So we can't just define a string here. We have to say type have results, and our params we can pluck from our event or our context. And in this case, we can just pass the event, because if we look, our found results event that we know we know we have because we're there, has a results value in it, and that happens to be the same type that our params need, so we can just give that event. Similarly for actions, we say type set results, and then we give it the params, and again, we happen to have the results just right there in the event, so we can do that. And for the rest of these, it's pretty much the same thing. I'm going to do a little pasting to get us up and running, but it's basically the same thing. Sometimes you give it context, sometimes you give it event. If you need some from the context and some from the event, you can do that. Okay, so our keyboard actor, the way we define actors is up here in our setup. We give some actors, our keyboard, and this is going to be a callback actor. So we build that with this xstate function called fromCallback. And that's going to give us a send back function that we can send the event back with. And then, wow, Copilot. So we need a handle key down function that pretty much nailed it. So if we switch on the key that's being hit, if it's down, then we want to highlight next. If it's up, we want to highlight previous. And if it's enter, we want to select. So just from the naming, it's figured that out. And then we want to add our event listener to window. And then what we return is a function to clean up our actor, similar to useEffect in React. And this is really important because our actor is invoked when we enter that selecting state. and then it's cleaned up as soon as we leave that selecting state. So when we're not in the selecting state, we're not listening to the keyboard events, which is pretty cool. Okay, so we've done our keyboard actor. Now we just need our search. So that is also going to be a from callback. And this time we need not just our send back, but we need to take an input. That's going to be our query, obviously, from the context. So first, synchronously, we can just handle the base case of if we don't have a query, return no results. Pretty good. And if we do have a query, then we're going to call our asynchronous API with our query. And when we get our results, we're going to send back our results of persons. Now our input is not strongly typed, but we can do that by adding some generic params here. We can say we expect this to be query string. And now our query is a string. And this is what's going to give us back our found results to get us out of our searching state. And this strong typing means that when we evoke this, when we invoke this actor, we need to give it the something that matches that. Okay, so we're looking pretty good now. Our machine definition is just over 200 lines, but we've designed it all visually. So let's quickly run through the simulator before we implement the UI. So this is our state machine, and we have this simulate button up here where we're in the no result state, but we can click on these things to simulate sending that event to the machine. And then we can see, okay, we're in this state, and we can stay in that state. And then when we select, we're in the no result state. And this simulator, especially if you're looking at a state machine that someone else wrote, is really useful to get a feel for how you flow through that machine. Okay, now let's implement the UI. The way we do this in React is with a hook called useMachine, well named, that we get from xstate. And that gives us a snapshot and a send in a tuple. And the send is just a function for us to send events to the machine. And it's all super strongly typed, so TypeScript won't let us send a malformed event, which is pretty cool. And then with our snapshot, we can get values out of the context, and we can check if we are in a particular state. Then we can say, if we're in this state, then display this. If we're in searching, then display our spinner. If we're in selecting, then display the options to be chosen. And when we mouse move, we highlight that thing, and then if we click, then we do select. So we're just hooking up the UI to the events that the machine needs. Notice there's no logic in here. There's no what to do if it's arrow up or arrow down. We're just sending, well, we're not even listening to the keyboard in here. So let's take this for a test drive. I've printed out this state that we're currently in down at the bottom. And so as we type, we go into searching, and then we can arrow up and down and choose, and now we have no results. And we can search again and choose, and now we're in no results. So this is working. Let's ship it. We've worked on this all week, and we can ship it on Friday afternoon. But then our manager calls us, and he's like, the back-end folks are really upset with you because you're hammering the server. You're killing our cloud credits. We need you to put a debounce into this so that on every key press, we're not hitting the server. And I don't know if you've implemented debounce before, but it's more complicated than it seems like it should be. So how are we going to do this debounce? Well, let's go over to our state chart here and create a state called debouncing. And let's have the transition that is a special kind of transition that is an after a certain delay that's going to take us into searching. And then all we need to do is on query change, rather than go into searching, we go into debouncing. And we're done. So now when we type in here, we go briefly into debouncing, and then we show our spinner, and we're searching. So that's how easy that was to implement a debounce visually. Like, I didn't write a line of code, I just dragged some arrows around, which I think is pretty cool. So I've made an attempt to try and implement this same thing using React and hooks. And as you might imagine, it's not that fun. Look something like this. We've got a bunch of different set use states for all our different bits of state that we need to maintain. And then we have this use effect that changes when query changes, and we have to do a bunch of sets before we call the async thing, and then we do a bunch of sets after, and then a finally to say no, we're no longer searching. And then down here, we have to have all this logic in our event handler of what to do, what all stuff to set when we click, and what all stuff to set when we hit enter. And there's just a bunch of code. There's a bunch of code in our JSX, right? All this logic has to be written in there. And experienced React developers will look at this and realize that that is a buggy piece of code there. There's all kinds of race conditions. You need to make sure that you're responding to the result, to the resolution of the promise that matches the query. It's like, it's really hard to write that particular sort of thing. That's why we have use query and things like that. So I'd like to go over some of the pros and cons of building UI with state machines. On the pro column, it lets you think visually. It lets you sort of draw out on a whiteboard how your component or page or whatever part of your app should look like and how it should behave. And you can do this with less technical members of your team, the product people that know how it should be but don't know about writing code. And then when you're done drawing on the whiteboard, it's already coded up. All you have to do is define those little bits of actions, and like you've in the design stage, you've done the coding already. And it helps you reason about time. Rather than having to hold the whole structure in your mind at once, you can just think about, okay, when we're in this state, what are the events we need to listen to, and what do we need to do when we get those events? And we need to go over to that state, and then when you're done thinking about that one, you can go and think locally about what needs to happen when you're in this other particular moment in time in another state, which is quite nice. And it's easy those state charts are fairly easy for non-technical team members to understand. I had a moment once where I had a state machine that I had built, and I was going over the state chart with one of my colleagues, and he said, wait a minute, that shouldn't go there, it should go over there. And like someone that's never written a line of code in his life, like found a bug, and we fixed it by dragging an arrow. Very, very cool. And it brings us back to the dream of the declarative UI of when you're in this state, draw this. When you're in this state, render this. When you're in this state, do this. And the logic and what happens on clicks and key presses and things are not in your JSX, your HTML. So the same way that we didn't like having HTML in our JavaScript back when React came out, and now I don't like having all that code in my HTML. It's like same thing. On the cons, it is a learning curve to understand that syntax of the JSON structure of the machine definition, and it will take some effort. But the visualizer, I think, helps that along quite a bit. And like any learning curve, once you get to the top, the view is quite nice. So before I go, I want to mention that I've recently started working at a company called Attio. We're building the best CRM on the market, and we just raised $1 billion and are hiring front-end, back-end, and design engineers. So If you're interested in a remote first team, working for a remote first team in Europe, DM me on Twitter, and we'll see if we can get you through the hiring process. Thank you very much.